So lesson 12, page 220, continuing on, this is going to be a new concept for you, so make sure we have our listening ears on. It'll be in description and graph form. Basically a piecewise function are, all functions have been pretty well solidified into a line, or dots. Now we're going to have different pieces. There are going to be different limitations depending on where you are at in the graph. So piecewise is just like it sounds. It is going to be pieces of graphs put together, pieces of limitations put together. So before we do that, let's just look at the first one. Georgia, since you commented that you like frozen yogurt, why don't you read number 1, please?
A self-serve frozen yogurt store sells servings up to 12 ounces. It charges 50 cents per ounce for a serving between 0 and 8 ounces, and $4 for any serving greater than 8 ounces and up to 12 ounces. Choose the graph that represents the
All right, so choose that graph that represents what Georgia's read. We're just going to kind of mention what each one represents. First one that is easiest is probably C. What are you paying for C?
$4 for any ounce of yogurt.
Yeah, so it's $4. And it's no matter the size. It seems like a good deal. Just load that baby up, $4. Okay, let's look at A. Try to find a point that we can see. You know, this one looks like it's a line, so obviously you're paying the same no matter what. How much are you paying? Well, let's look at this point. Looks like $1 is 2 ounces, so how much are you paying per ounce? Yeah, so you're paying 50 cents per ounce. Again, no matter the size. Linear relationship. Same looks like it can be true for D. That is a nice line as well. So $1 for 3 ounces. So how much am I paying per ounce?
25 cents.
No, that'd be 4 ounces. 33.3, a third of $1. Again, no matter the size, paying the same. Now B is the only one that's left. That's the only one that is not a line that continues on forever. This one has a little bit of variation in it, right? Different pieces. So as Georgia read, it's 50 cents per ounce between 0 and 8 ounces. So here is your 50 cents per ounce. But then once we get to 8 to 12, it's just a flat fee of $4. So that is a good example of a piecewise function. So between 0 and 8, it's 50 cents an ounce. As soon as you get to 8 or more, it is a flat fee
So that's what we're
of $4. That's what we're doing today.
That'd be awesome.
That would be awesome. They do cap it at 12, so you can't totally load that thing up. All right, so example 2. The relationship between postage rate and the weight of a letter can be defined by a piecewise function. The graph shows a 2018 postage rates using regular service to mail a letter. Obviously, it is based on weight and also size. This one's comparing weight and cost. Now let's discuss this a little bit. You can see there's 4 different pieces to this function. Remember what an open circle means?
No.
Like, what's the difference between that and that? Remember from our day's graph and number lines? Other way. Yeah. Open circle means excluded. does not include that number. Closed circle does include it.
That makes sense.
And it's a big difference, right? So if I'm looking at this one, you'll notice that they are overlapping here at 1. Well, this one is included. This one does not include 1. Okay? Because you can't have 2 dots here that would represent the same thing and same weight and be different prices. So that's why you see open circles and closed.
Why couldn't they just put that second line not on 1?
Because then it'd count.
Because 1.001 would still be a part of it.
Oh, so anything after that.
Yep.
Okay.
That's what that means. All right, so let's see if we can answer the question. Now be careful, watch open or closed circles. What is the price of a letter that has 1 ounce? So x equals 1 is what that means. Which piece of my graph is that a part of? How much then?
50 cents.
Yeah, so 1 is included here. That's why it's important to not get the circles mixed up. It is not included here. It's got to be the first one. So that is 50 cents for that letter. How about 1.1?
70 cents? I don't know what that.
Yeah, 1.1 is going to be here. Obviously less than 75, then it's going to kind of be an approximation. What'd you say, 70?
Yeah.
You go to 70? Anybody want to go more or less than that? I'm going to protect myself by saying about. And how about 0.9 ounces?
Wait, sorry. Oh, 50 cents again.
Yeah, 0.9 is going to be about right here. That'll be part of that first piece again. So that would be 50 cents as well. All right. Somebody other than Georgia needs to answer this one. Samir, I think you can. Ready for it? A letter costs 92 cents to mail. How much did the letter weigh? Okay. That would be an example of one that would work. Samantha?
Oh, I think it's 2
2 ounces. Okay. Connor?
Between 2.1 and 3 ounces.
Okay, between 2.1 and 3.
What about 2.00000?
Yeah, what about 2.00001, Connor?
That would work, yeah.
That would work as well. Yes. So I'm going to say it weighs more than 2 ounces. Notice I didn't say it includes it. It says more than 2. And then how about the other side?
It can be 3.
It can be 3. So I'm going to say, but at most 3 ounces. So it does include 3, does not include 2. Okay, so if we were going to write that, this is what it would look like as an inequality. W is between 2 and 3, does not include 2. There's no equal sign under here, but it does include 3. All right, Kieran and Maya wrote some rules about the same graph, but each of them made some errors. So let's look at Kieran's first, one on the left. Can you see what Kieran did wrong? Mr. Tolp.
On the first one, it can't be equal to 0.
Okay, so what sign is wrong? The first one?
Yeah.
On all of them or just one?
What do you mean?
Is it just the first one?
I just looked at the first one. And then
All of them below are supposed to be changed.
Yeah, they're all wrong there.
So it just has to be greater than.
Yep. Does not include, let's see, all the circles to start are open. So it should be just a W is greater than symbol, and that is true for all of them. Everything else is correct. Again, 4 different pieces of that function. So then it should be pretty easy to see what Maya did. Georgia?
The second one has to have a line.
Yeah, so we already did that. We already wrote them correct. The second dot is filled in on that example. Questions on that one before we move on? Open, close circle. Okay, next page. We're going to skip the Are You Ready on 222 and go into the bike problem. Jackson's going to read question 3 for us, please.
Function C represents the dollar cost of renting a bike from a bike sharing service with T units. Here are the rules describing the function.
All right. So what does C represent? Cost. Okay, so you're renting a bike. Obviously, the longer you have a bike, the more money it's going to cost you. Now we're going to graph this. We're going to make this piece this function together. So let's compute this first. We'll use a table, then we'll make the graph. If I rent the bike for 0 minutes, it's going to cost me $0. If I rent the bike for 10 minutes,
$2.50.
yeah, so from 0 to 30 minutes is, obviously 10 is included there, so it's going to be $2.50. 25? Okay, somebody other than Georgia. 60.
750.
No.
Amy, what do you think?
I don't get it.
60 minutes. You gotta find out where 60 minutes is, and what range.
$5,
Yeah, so why is it not this one?
because that one says under equal.
Yeah, T is bigger than 60. There's no equal sign there. It does not include 60. 60 is included in this one. Equal sign. $5 is correct. 75. 75 would be in this range. 130. 180. Yeah, so that should be pretty simple. You see where the range is, you write the cost down. Sketch a graph. All right, so when does it cost $2.50?
Zero.
Okay, closed circle or open? Open circle at 0. Makes sense, you can't rent it for 0 minutes. 30? Closed circle. Connect the dots. Okay, why don't you see if you can continue that on? Just graphing those ranges, watch if it's open circle or closed. You guys already got it done. Yeah, try and roast us out of here, Becky, or what?
No,
was, and then they jacked the heat up.
Yeah, it was fine. It just smells bad.
So what do you think of these so far?
Easy.
Eh. Eh. I can't even go to 240, it's gonna continue on past that.
Yeah, how do we do that? Do we just go?
Well, it says at most 240s, so. I'm gonna stop there. There it is, pieced together. Again, watch the circles, open or close, make a big difference. Make a big difference. Question 2, describe in words price. Okay, so if you had to describe to somebody how much this bike costs, what are you saying?
However you read it.
Moves up $250 every single 30 minutes.
So every half hour?
Price. Pieces.
Okay. Looks like that's not true forever, though.
Until 2.5 hours.
What's that?
Until 2.5 hour, 150 minutes, then it goes to 720.
Yeah. So it almost looks like they have a maximum fee.
$15.
$15 appears to be the max. And judging by this, what is the maximum amount of time I can have the bike then?
720.
720 minutes. What is that?
In hours?
6. No.
So 720 divided by 60.
12.
12. So I better include that. Bike can be rented up to 12 hours. All right, now let's show that as a function notation. All right, the domain. Remember, domain is the X, the input. So what are my X values? In this case, minutes. What is the lowest amount of time I'm going to rent the bike for? 0. Notice it does not include 0. There's no equal sign there. So between 0 and maximum amount of time I can have the bike?
12 hours.
Yeah, 12 hours.
Is there parentheses right there?
It's a bracket. You can do parentheses. All right, the range. Now be careful. You might be tempted to say anywhere between 0 and 15. That is not true. Between 250. Everything between 250 and 15.
Integers of 2.5.
With multiples of 2.5, you'd have to list as well. Or you could just list them. 250, $5, 750, 10, 1250, 15. Or yes, you could have said between 250 and 15 and said multiples of 250. And not every number gets picked. We're gonna do one of those last ones. We're just gonna graph it together though. Got a preference? You wanna do left one or right one?
Left one.
Alright, find some blank paper there somewhere, maybe in the back on one of your note pages. And we'll just roughly sketch one of these together. If you want graph paper, I got some of that here for you. It's up to you if you want a big sheet or a little one.
How big do we?
Did you say left one?
Yes.
Okay, so we're gonna graph this one. Okay, if you can do this problem, you can do any of them that you'll see. This one doesn't give you really any data points or anything like that. All it does is say here, graph it. Was gonna have some pieces of paper and say piece them together, but I think if you can just do it by hand, you could pretty much do any of it. So I'm just gonna start by drawing my X and Y axes. So somewhere, wherever you're doing this, if you're sketching it, that's fine as well. Don't need graph paper. All right, from -10 to -5, not including it, my Y value is 5. So your first one here, this is your Y value. That's my height. And of course, this would be my X is my input. So -10 to -5. 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my -10, down 5. Appears to be an open circle. And then I'm going all the way to 5, -5, so I'm going right 5 spots. I do not really have to put it in a closed or an open circle because I see it changes on the next one at the same spot.
But wouldn't you have to put an open circle?
It would be, but the next one you're going to fill it in anyway.
Oh,
So you can start with that, that's fine. All right, now we're graphing X. Okay, Y equals X, it's just an equation, it's a line, slope of 1. So your dots go up 1, right 1, up 1, right 1, up 1, right 1. How far? Up to 0. So we are connecting those 2 points. And then I'm going to fill in that circle, Georgia, again because of that symbol right there. So it's not included on the first one, but it continues on. It is included in the second one, so it's filled in.
I don't understand like the slope that we're doing.
Y equals 1. There's your equation.
So
It doesn't get any more basic than that.
For the Y is the,
Y is the height. You're graphing Y equals X. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Until 0. Okay, then from 0 to 3, where's my height? Okay, it's not an X now.
then what is the point?
That's your height. You just go, just like we did to the first one where we're down 5. Now it's 1, so my graph is going to move up to here. Open or close circle at 1. Close circle at 0. And how far right do I go? To 3. 1, 2, 3. Open circle. All right, next one. X minus 2. So again, I am just concerned about my slope there. What's my slope? What's the number in front of the X? What number is in front of the X?
no.
It's the same slope as last time. Now you might say, why is it a minus 2? I'll show you that in a second. So we're going all the way to 8. Up 1, over 1, all the way to 8. So that's 4, 5, 6, 7, 8.
Wouldn't that circle not be closed?
Circle will now be closed there. Now you might say, why does that one look different? Why is it x minus 2? Well, if you were to continue that line on, look at what the y-intercept would be. What would the y-intercept be? -2, so that's the equation of that line is all that meant. All right, the last one. What's my height? My height is 6. Am I at 6 now? 1, 2, 3, 4, 5, 6. I'm at 6 now, so I'm going all the way to 10. So this was at 8, 8, 6, going to 10. This dot gets filled in. Last dot is open. So those are certainly the most challenging when it doesn't give you any information. You're gonna see more like the bike one where it gives you more information. Here's a chart, okay, now let's transfer the chart to a graph and so on. So I would say that one again is a challenge problem.
Where do you have those on the lessons?
Yeah, all of them. Page 241. Take a look at your homework.
You're on lesson 13, 14.
I'm on lesson 14. I said 214? Oh, I don't know why I said 241. 226, is that better?
Yeah.
All right. Complete the table, sketch, make sure your answers C and D. Explain, explain. 2, explain. Okay, graphing, intervals. So for number 4, you're gonna write the intervals. Do you know what intervals are? That would be like these. These are known as intervals. So they do take a little time, only 6 questions today. So you got the rest of the hour to roll on that.